transportation problem using the modified distribution method.
So welcome to this video using the modified distribution method. We use it to solve the transportation problem, okay, and achieve an optimal solution. Okay, this is an example. We're going to use it on this. For example, you have this warehouse 1, okay. You have the supplies, you have 150 in warehouse 1, you have 175 in warehouse 2, you have 275 units in warehouse 3. And also the destination where they are being shipped to, you have for destination 1, you have 200 that is required there. For destination 2, we have 100. For destination 3, we have 300. If we add this together, it will give us 600. Okay. If we add this together as well, 175, 275, it will give us like 450. Okay. Add it to 150, it will give us 600. So total supply is equal to total demand, which is 600 units. And this is what we call a balanced transportation problem. Okay. For the unbalanced type, where you have the supply, okay, exceeding the demand, or demand exceeding the supply, we'll treat that in another video. Now, in this case, let's see how to go about it. Now, first of all, before we start, let's look at the convention used. For some authors, they write the unit cost of transportation in this big box here, the bigger box, and they write the allocations in these smaller boxes, okay? They put the allocation here, put the allocation here, just like that, okay? While other authors, like this, they write the unit cost here, and write the allocation here, giving it more attention. For me, I feel this one should be better, because the object of discussion is the items, the number of items you are allocating, okay, to each cell. Okay, so I prefer to use this system. So we're going to use this system in our calculation. Now, how do you go about solving a transportation problem and having an optimal solution? Number one, find the initial feasible basic solution. To do that, you will find the initial feasible basic solution by using any of the northwest corner method, or the least cost method, or the Vogel's approximation method. That's the first step. You calculate and get the solution for the first step. And that's what we call the initial feasible basic solution. Here we're going to treat the first point, which is finding an initial feasible basic solution. Here we're going to use the northwest corner method. And using the northwest corner method, we just look at this is the supply, demand, okay? You always go up to the left, come here. At this point here, we have 150 as supply, and we have demand to be 200, which is the lesser value. It's 150, so we write 150 here, okay? Then you subtract it from that, cancel, here becomes 0, okay? The same amount, you remove it from here, cancel, 150 from 200, you have 50. Then you look at the row or column that has 0, that's exhausted its allocation, you cross it out, cross this one out, cross this one out. Okay. Then you go next to this, come here, okay. Look at at this point, the demand is 50 and the supply is 175. You take the lesser value, okay, take the lesser value. So 50 and 175, 50 is smaller, so we write 50 there, okay, and here, cancel, becomes 0, remove the same 50 from here, that will be what? That will be 125, okay, yes. Then the column that has exhausted its allocation, you cross it out. You go next to this, okay, northwest corner. You're always starting from the northwest corner, that's to your left, top left. So you come here, on this row, warehouse 2, we have 125, okay, and the demand there is 100, which is a smaller value, 100. So you write 100 there, 100, okay, like that, 0, okay. Subtract it from here to 100 from there, we are left with 25, okay. Then you look at it, you have already exhausted this column, then you strike it out. Now we are left with this We're left with this. This is the next cell. We're left with this. Here we have warehouse 2, 25. The demand there is 300, which is smaller. Between 25 and 300 is 25. So you write 25 there. 25, okay. 25 from here, 0, okay. 25 from here, okay, is going to give us this 275, okay. You have 275. 275, okay. Now, what is left here? The demand is 275. The supply is 275. So that means we are not. That is 275. That is all. So with this, we have finished the first allocation. Before you can apply the Modi method, after the allocation, you make sure that you check for degeneracy. That is, you make sure that the number of occupied cells should be equal to M plus N minus 1, where M is the number of rows, N is the number of columns, okay, minus 1. So let's check for that. Where here we have how many rows? We have 1, 2, 3. 3 rows. So we have 3. Okay. Then the number of columns, 1, 2, 3. That's 3. Plus 3 minus 1. That's equal to this is 6 minus 1. That is 5. Now let's count the number of entries. We have 1, 2, 3, 4, 5. That's correct. Which means we have a non-degenerate solution. Okay, if it's not equal to 5, then we have a degenerate solution, and we have a way of going about that. Okay, but for this, it means we can apply the Modi method.
Please share this video and subscribe to my channel. For more, please visit my website, teachwithcomputer.com.
This setting, okay, this allocation is going to serve as a starting point, okay, for using the modified distribution method. So I'm going to copy it out so that it can be clearer for us. Now here we are. We have written out the allocation, okay, from the first calculation using the northwest corner method. Step 2, you calculate the UI and VJ for occupied cells. Okay. Now you compute the UI and VJ values for each occupied cell. That is UI plus VJ equal to Cij, where Cij is the unit transportation cost for the cell. Okay. And before you start using this formula, before you start carrying out the computation, you set any of the UIs to 0. Okay. To begin the calculation, you set any of the UIs to 0. Okay. Now the next thing we're going to do is to calculate the UIs and the VJs for the allocated cells. Okay, so we go straight ahead. The formula is Cij, okay, is equal to UI plus VJ. Okay, so you come here, you write U1, the U1 first row. This U2, this U3, this is V1, this V2, this V3. Okay, now you set any of the U's to 0. And if you look at it, just check the one that has more than one item is the one you should set to 0, so that will be easier for you. So this has 3 items. You can say let U2 be equal to 0. Okay, so if U2 is 0, then U2, okay, plus V1 is equal to 9. Okay, this Cij is the unit transportation cost for that cell. It's the unit transportation cost for the cell. Okay, so you can see 0 plus something is equal to 9. Means V1 is 9. Okay. U2, okay, plus V2 is equal to 12. It means here is 12. Okay. Coming here, U2 plus V3 is equal to 13. It means V3 is 13. Okay, so we've gotten all this. We are left with U1 and U3. We can come here, we can trace this now. Already we have V3 here to be 13. Okay, we have U3 here. So V3 plus U3 is equal to 16. Okay, therefore it means this is what? 3. Okay, this is 3. Okay, then the next one is here. U1 plus V1 is equal to 8, isn't it? U1 plus V1 is equal to 8. So it means our U1 is what? It's minus 1. That is it. That is it. With this, we've been able to calculate the values for our UIs and our VJs. Okay, this is step 2. We now go to step 3 to calculate the delta IJ for each unoccupied cell. This we have done is for the occupied cells. You calculate the delta IJ for unoccupied cells. Now, for each unoccupied cell, you compute the delta IJ, which is the opportunity cost for non-basic variables entering the basis. Okay, and this is given by delta IJ is equal to Cij, okay, minus bracket open UI plus Vj. We now calculate the delta Ij for each of the unoccupied cells. So we have delta Ij is equal to Cij, okay, minus bracket open Ui plus Vj. This is the formula we're going to use. And we'll be applying it on the unallocated cells. Let's mark them out. That is these cells. This one, this, and this. Okay? We're going to calculate delta Ij for these cells. For the first one here, this is what? This is row 1, column 2. So we have delta, okay, 1, 2 is equal to Cij, that's C12, okay, which is 6, minus bracket open U1, okay, which is what? Minus 1, plus V2, which is 12. Okay, that will be equal to, this will give us 11. 6 minus 11 will be minus 5. Okay, the next one is this delta 1, 3, okay, is equal to, that is delta row 1, column 3, is equal to the Cij there, 10, okay, minus bracket open U1, which is minus 1, plus V3, and V3 is what? 13, okay, that will be equal to, this will give us 12, 10 minus 12 is minus 2. And the next one is this cell here, delta 3, 1, okay, so delta 3, 1 is equal to 14 minus bracket open, okay, U3 is 3, okay, plus V1, V1 is 9. That will be equal to, this is 12, okay, 12, 14 minus 12 is 2. And the last one here, delta 3, 2. So we have delta 3, 2, okay, is equal to Cij, okay, 3, 2, which is 9, okay, minus bracket open, okay, we have U3 there is what? Is 3, plus V2, V2 is 12, that will be equal to 3 plus 12 is 15, okay, 15, 9 minus 15, that's minus 6. And so the next step is to determine which variable, okay, that will enter the basis, okay. The new basic cell is the cell with the most negative delta ij, because by the time you now have series of negative values or even just one negative value, it after calculating delta ij, okay, if any of them has a negative value, then you take it. But if it is more than one, then you take the highest negative value, okay, and this cell enters the basis. It reduces the unit transportation cost the most and hence has the largest opportunity cost. Okay, then it is that cell you are going to use for the looping. The variable that is entering the basis, you now look at all these values here, the delta ij's, okay, take the most negative value there, which is this, minus 6. Is the most negative, minus 6, okay, then which cell is that? Delta 32. That is 32, that's 32, 32. Now have it, this cell is entering the basis. Okay, so let's go and carry out our looping. We now form a loop with this point. Now, these are the rules for constructing a loop, assuming the variable that is entering the basis is at this point. Okay, variable entering the basis at this point. Then you loop. That means you move in horizontal and vertical directions. Like this, like this, like this, like this. That is, this is counterclockwise, or you can as well go clockwise, like that. Okay. Since we have known the variable entering the basis, assuming it is at this point, okay, you write positive here, plus the next cell, minus the next cell, plus the next cell, minus. Then you now look at the the diagonals, okay, the two diagonals that are having minus, two diagonals that are minus. Then you now take the lesser value. And you subtract it from the two diagonals. That value, you add it to the other two diagonals that is very positive sign. Okay, you add it to this and this. For example, if you have, let's say 10 as the lesser diagonal or the minus diagonal, okay, let's say 10. You subtract 10 from here, subtract 10 from here. Then you add 10 to this and you add 10 to this. Okay, that's it. So when I use figures to explain, you get it clearer. Then these are the rules to be followed. The loop is a closed path that starts and ends at the starting point. So if you are starting the loop from here, you must go, and come back and end at that starting point. Then loop is made up of alternating horizontal and vertical lines. Okay, so you must not go diagonally. You must go horizontally or vertically. Then 3, turn only at currently allocated cells and at 90 degrees. Okay, so if you are turning, as you are moving, you must turn only at a cell that has entries, okay, an allocated cell. You can't turn at an empty cell, and you must turn either left or right. These are the rules for forming a loop. To carry out our loop, okay, to form our loop, we know the variable is coming in here, okay. The variable entering the basis is this variable in this cell, which is cell, 3, 2, okay. So this is the point. So from here, we're going to loop here, okay? You go down, right, up, like that, or you go up, like that, okay? We're going to form a closed loop. So we move right, can go right here, 1, 2, 3, 4, can form a closed loop here, okay? Can form a closed loop here. Can't go here. If we go here, see this place is empty, you must turn at an allocated cell. So from here, go right up, and let me draw the line. We go like this, go this way, and we take it down to close the loop. And we go down and close the loop like this. Yes, so this is our loop. This is our loop, okay? So what we'll do, remember this 100, this is 275. So let's draw. This is the starting point of the loop. Okay, this is starting point. You now write there, this is starting point. We're going to the right. There will be positive. Okay, with positive. Here will be negative. This point will be negative. Okay. Here will be positive. And here will be negative. That's what you do. That's the loop. Either you go this way, clockwise, or anti-clockwise. So this is negative, this is positive, this is negative. So the next thing is to ask, which of these variables, okay, are the diagonals are we going to subtract from? Okay, here we have 100, here we have 275. look at the diagonal, okay, that is having minus, this minus, this is minus, this minus, this minus. Then you take the lesser value. Here is 275, here is 100. So this is what we're going to take. We take 100, we subtract 100 from here, subtract 100 from here, okay, then add the same 100 to the other positive diagonals, okay. So to carry out our reallocation, okay, we said we're removing 100 from here, okay, so here becomes 0, okay, removing 100 from here becomes 175, okay, 175, then we're adding the 100 to the other two diagonals. So here, no value here before, it comes into the basis, we have 100, okay, then here you add 100 to this as well, so you are adding 100 to 25, so here becomes 125. 125. So this is our new allocation. Okay, this is our new allocation. So with this, we now go and test for optimality. Okay, by calculating the UI and VJs again. Okay, and now also solving for the delta IJs for this table. Here we're going to carry out the second iteration to sort of drive towards optimality, okay? But before we continue, I want you to subscribe to this my video, okay? Let me give you some time to click on the subscribe button below, and also at the end of the video, you also share it. Let me give you some time. Okay, let's continue. Now, the next thing we're going to do is to iterate again, okay? So talk about the values of the UIs and the VJs. Now, some authors will tell you always set U1 equal to 0. Whichever value of UIs that you set to 0, it doesn't matter, okay? You always arrive at the same answer, okay? For example, you may decide to set U1 to 0, U2 to 0, or U3 to 0. In this case, I use the systems here so that to be easier for you to calculate, to avoid errors. So look at this one has 2. There are 2 here. Okay, 2 on this row, 2 on this row. So we can use either U2 or U3. You can set either U2 to 0 or U3 to 0. If you set U1 to 0, it may be more difficult for you to calculate, okay? So let's use this one because we have 2 values here. By the time you set U3 to 0, already you have values for V2 and V3, okay? So let's set U3 equal to 0. Good, that was it. If U3 is 0, and this is 9, it means here is 9 too, okay? If U3 is 0, U3 plus V3 should give us 16. Okay, and if this is 0, it means this is 16. We've gotten 1, 2, 3 already. The next thing is remaining these 2. You come here. If V3, you can see this, V3 plus U2 will give us this point here, 13. Okay, so 16 plus U2 will give us 13. It means this one is minus 3. Okay. Now, look at this. V1 plus U2 is equal to 9. V1 plus U2 is equal to 9. So what is the value of V1? Okay. V1 is going to be 12. Yes, V1 is 12. So that 12 minus 3 will give us 9. You cannot come here. You see, this is 12. V1 plus U1 is equal to 8. Okay. So this means U1 is what? Is minus 4. Okay, for the sum of the two numbers to give us 8. So with this, we've been able to calculate for the allocated cells. The next step is to look for delta ij. Here, carrying out the second iteration, we have our delta ij is equal to Cij, okay, minus Ui plus Vj. Okay, so we come here for the what? For the unoccupied cells, which is this. So this first one here, calculate for this. This is delta 1, 2. So we have delta 1, 2 is equal to C 1, 2 here. Okay, this is 6 minus U1, which is minus 4, plus V2, okay, V2 is 9. That will be equal to, this one as a whole will give us 5. 6 minus 5 is 1. The next cell is this, that's delta 1, 3. Delta 1, 3 is equal to 10 minus bracket open, okay, U1, okay, U1 minus 4 plus V3 is 16, that will be equal to 16 minus 4 is going to give us 4. 16 minus 4 is going to give us 12, okay. 10 minus 12 is minus 2, okay, that will be minus 2. The next one is delta, this point, 2, 2, okay, that will be equal to, that's 12, minus bracket open into U2 minus 3 plus V2 9, that will be equal to, from here, 9 minus 3 is going to give us 6. 12 minus 6 is 6. The next one is this, that is delta 3, 1 is equal to 14, okay, minus bracket open U3, which is 0, plus V1 is 12, and that will be equal to 14 minus 12, which is 2. Now if we check, look at this, is our solution optimal? No, we still have minus 2 here. We still have a negative value here. Therefore, our solution is not optimal. We still need to iterate again. So you check which cell is there. What variable is coming in? That's the cell 1, 3. Okay, 1, 3. That is 1, 3. So here is coming. The variable is coming into the basis. Okay, it's coming to the basis. It's coming to the basis. So we go next and loop. Okay, we're going to carry out our looping. It's coming in here. We'll do our looping and we continue from there. Now that we know that this is the cell that's coming in, okay, so we start the loop from here. Okay, how do we move? Can go like this: 1, 2, 3, 4, or like this: 1, 2, 3, 4, either clockwise or counterclockwise. Okay, we'll form our loop. So let me draw the loop like this. Okay. Like this, we go up. Okay, like this. Come back again to close the loop. Come back again to close the loop. That's the loop. There's the loop. Okay. Down, left, up, right. This is our loop. Then after that, we come here. The starting point here will be positive. Okay, it's positive. Next one, negative. Next one, positive. Next one, negative. Okay, so we're going to reallocate our values here. Okay. Now here are our values. Okay, our values want to carry out the allocation. Then we have here, this is 150, this is 125. Okay, these are negative diagonals. Okay, negative, positive. So here you have 150 here at this minus, you have 125 here at this minus. The lesser value is 125, so we subtract 125 from these two values, okay? 125 from here, 125 from here. We add the same value to the other diagonals as we did it the other time. So we come here, 125, okay? From this, we are left with 25. Okay, that was 25. Then here, 125 from here is going to give us 0. That will be 0, okay? Then 125 plus this place comes in fully, 125, okay? Then 125 plus 50, okay, will be 175. Yes, so this is the new allocation, okay? This is the new allocation. You add everything together, they'll give you the same total value for the supply and the demand. This is the new allocation, okay? Then after this, we need to carry out another iteration. Okay, need to carry out another iteration to determine whether this allocation is optimal or not. Looking at this allocation, let us now carry out the calculation for UIs and VJs. You said we can set any of them to be 0. You have these two are close together. This one, we have 2 here, we have 2 here. So ordinarily we would have done, but I just want you to know that if you set any of them to be 0, you get the same result. So let's set this to be 0. U1 equal to 0. Okay, so you have U1 plus V1 is equal to 8. Therefore, V1 is 8, okay? Here, U1 plus V3 is equal to 10. It means V3 is 10, okay? Because since U1 is already 0. After that, we go down now. We come here. We have V1 here, okay? U2 plus V8 is equal to 9, okay? It means this is 1, okay? These two, addition of the 2 give us 9. It means this is 1. We come down. We come here. This is 10. We have this already. So we have it. U3, okay, plus V3 is equal to 16. Okay, and here is 10 already. It means this one will be 6. Okay, then what's remaining again? We have this mini V2. U3 plus V2 is equal to 9. And here is 6. It means here is 3. Okay, so that's it. So we have been able to calculate the values of what? UIs and the VIs. Here, let us calculate the value for the delta ij. Remember, delta ij is equal to what? Cij, okay, minus ui plus vj, okay, for the unoccupied cells. Okay, so coming to this point, there is delta 1, 2. So we have delta 1, 2 is equal to Cij, which is this 6, minus bracket open U1 0 plus V2, V2 is 3, okay, that will be equal to 3. The next one is this item, okay, this cell, that's delta 2, 2. Delta 2, 2 is equal to 12 minus bracket open, okay, 12 minus U2, U2 is 1, plus V2 is 3, that will be equal to, this is 4, 12 minus 4, that's 8. The next one is this, delta 2, 3. 2, 3 is equal to the value here, okay, 13, minus bracket open, U2, which is 1, plus V3 is what? 10, which is equal to, this is 11, 13 minus 11 is going to give us 2. Then the next one is this is the last one, okay, this is delta 3, 1 is equal to 14 minus bracket open, okay, U3, which is 6, plus V1 is 8, that will be equal to, this is 14, that's equal to 0. Therefore, you can see that the solution is optimal, but there's an alternative optimal solution as well, since we have 0 among the options. And with this, we can calculate the transportation cost. We don't need to iterate again. This is the optimal solution. So calculate the transportation cost for this arrangement. So we go there and we say cost, okay, total cost, okay, of transportation, okay, okay, is equal to, you multiply the quantity by the unit price, okay, that will be 25 by 8, 25 times 8 plus 125 times 10, okay, plus 175, okay, times 9, plus 100 times 9, plus 175 times 16. And this will give us $6725. That is the total cost of transportation. And this is the optimal cost of transportation. Okay? And with this, we have come to the end of this video. I want you to actually subscribe to my channel. At the same time, get a book. The book is called The Digital Teacher. You can see the way I've been clicking since it's Click to Teach. It's called CCS Card. I've taught a lot of things in that book. Just go to my website, teachwithcomputer.com, and get that book. You have a lot to gain in that book, because whether you're a teacher, whether you're a lecturer, whether you're a student, even as a worker, okay, you need this book because it teaches a lot of things. It's so detailed. How to computerize pedagogy is in that book. Just visit my website and you get the book. And also look out for my channel, Digital School, and get more videos on this topic and other areas in life. Thanks for watching.